Here we have the equation 5x squared plus y equal to 12, and we want to find y prime, which is the derivative of y with respect to x, or dy dx. And so to find the derivative of y, what we can do with this, one way is to solve this equation for y. And so we subtract 5x squared from both sides, and we get y equal to 12 minus 5x squared, and so y prime, which is dy dx, or the derivative of y with respect to x. And the derivative for the constant 12 is 0. The derivative of 5x squared would be 5 times the derivative of x squared, which would be 5 times derivative of x squared is 2x. And so the answer is negative 10x. We could also leave the equation as it is and then find the derivative of y with respect to x by using what's called implicit differentiation. And so it's done as follows. We want to find dy dx, which is the derivative of y with respect to x. And so we're doing derivative of respect to x, and then here we have 3 terms. Any term that has x only, then we just do the regular, the usual derivative. Any term that's just constant, then we do the regular or the usual derivative. But any term that has a y, then we need to use the chain rule. Here as follows. And so here, this term only has x only. It doesn't have a y in there. In here, there's no y here. And so what we do, we just do the regular derivative. So the derivative be 5 times the derivative of x squared is 2x. And then on this side, the constant 12, the usual derivative of the constant is 0. But for the y here, this is 1y. And so we will use the chain rule on this one. And so we need to do the derivative of 1y, which is 1, and then times the derivative of y, which is dy dx. So one more time, if we do derivative with respect to x, and the variable here is different than x, namely the variable here is y, then we need to do the usual derivative, and then we have to times the derivative of y, which is using the chain rule. And so now we get 10x plus dy dx equal to 0. And then subtract 10x from both sides, and then we get dy dx equal to negative 10x, which is the same thing as what we got up here. And so the question becomes why do we have to use implicit differentiation when we can do it this way? We can only do it this way if we can solve for y. And there are equations where it's difficult to solve for y, and we have to use what's called implicit differentiation to find the derivative of y with respect to x.